Hello students, we are continuing with band theory of solids. In the previous video, we have discussed about the formation of energy bands in case of solids. And also we have discussed about the classification of solids on the basis of band theory into conductors, semiconductors, and insulators. Today we are going to discuss about energy band formation in case of three types of material, that is, one is conductor, one is semiconductor, and another one is insulator. That is, three examples we are going to look into. One is lithium, and the second one is silicon, and the third one is diamond. As we know, the lithium is a conducting material, silicon is a semiconducting material, and diamond is an insulator. Let us understand why lithium acts as a conductor, silicon acts as a semiconductor, and diamond acts as a insulating material on the basis of band theory of solids. For this, one must know about the basic thing, that is electronic configuration. Electronic configuration is nothing but accommodating the electrons in different subshells around the nucleus through the electronic configuration. For example, if I take, or electronic configuration can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and so on. So these are the subshells which are around the nucleus, and in 1s shell we can accommodate maximum of 2 electrons. In 2s we can accommodate 2 electrons. In 2p we can accommodate 6 electrons, and so on. Now if I want to write electronic configuration of any material, I am going to follow this rule. For example, let us take the first one, that is lithium. Lithium, as we all know, it belongs to group 1 element in periodic table. The number of electrons present in lithium are 3, or atomic number of lithium is 3. If I want to write the electronic configuration for lithium, I am going to follow this rule. So how I am going to write it as, the out of 3 electrons, first 2 electrons will occupy 1s2 subshell, and one more remaining electron will occupy the 2s level, and it is 2s1. From this we can clearly see that 1s is completely filled as its capacity is 2, and 2s level is half filled as its capacity is 2, and the available electron is only 1. So if I take the atom of the lithium, this is the nucleus, this is the first shell, where 1s shell, it is accommodated with 2 electrons, and the outermost here is 2s, it is accommodated with 1 electron. Similarly, if you bring one more atom of lithium closer to this also looks something similar to this, and 2 electrons in 1s level and 1 electron in the 2s level. Now, if these two atoms approach each other, what is going to happen? As discussed in case of formation of energy bands in the solid, when these atoms interact with each other, first the outermost electrons will interact with each other, and the energy of some electrons is going to reduce and the energy of some electrons is going to increase, and it is going to lead to the number of energy levels. After this, still if you decrease the distance between the two atoms, these two electrons from 1s level and these two electrons from 1s level of this lithium atom interact with each other and the energy levels split. For example, if I take this 2s level, if this is the 2s level, the available capacity of the 2s state, for this it is 2 and for this also it is 2. So the capacity is 4n states. But as we have only one electron and one electron, it is going to split into 2. So we have only n levels, 2 levels. Similarly, if I take the innermost orbit, that is the level 1s, it is going to split into 4. 1, 2, 3 and 4. It is going to split into 4. As we have considered 2 atoms, it will be 2n electrons. And the states will be 2n states. Now, if we assume the lithium as the solid material, and when I take the solid material of the lithium, the number of atoms interacting in the solid will be maybe n in number. N atoms will be interacting. So 1, 2, 3, 4, 5, so on up till n atoms. Now each atom will have the electronic configuration of this and this. Now as all the atoms are brought closer, all start interacting. So the 1s level is going to split into n levels, or it is 2n levels. The capacity of this is 2n electrons make the 1s level, whereas this will be half of the 1s, because we have only 1 electron instead of 2 electrons in 2s level. So this will be n number of electrons, but the states will be, here we have 2n states, here we will be having 2n states. States are 2n, but only the electrons are 2n. So let's do this correction also. So this level is the 2s level. This picture of the solid material of the lithium can be understood by plotting a graph of interatomic distance and the energy of the electrons. In that, we are going to take along the x-axis the energy of the electrons, and along the y-axis interatomic distance. As we have considered the case of n number of atoms in case of lithium. So as the interatomic distance goes on reducing, the energy levels are going to split. For example, first we will draw 1s level here. This is the 1s level. above to this, the energy of 2s level is higher, and this is the 2s level. As we see here, as the atoms come closer to each other, first the outer shells electron are going to interact with each other. So as we go on decreasing the distance between the interatomics, first 2s level is going to split. We know that it has only one electron, or it is n electrons, and it is 2n state. The capacity is 2n, but it is filled with only one electron. Some of the electrons reduce their energy, some of the electron increase their energy out of these n number of electrons. Similarly, first as the 2s electrons have interacted, now if you decrease the distance further between the atoms, 1s level electrons are going to change their energy such that some of the electrons will reduce the energy, some of the electrons will increase their energy. If further you decrease the energy, these levels are going to go with the higher value of the energy. In this fashion, this 1s level splits or forms the band of energy which is completely filled. As we know, the capacity of 1s is 2n states, and the filled states are also 2n electrons. So it is completely filled, no issue with this, and we can show this as a particular band of energy corresponding to 1s level. Now if I take this part, this also forms a energy level or energy band, out of which some part is filled, some part is empty. The capacity is 2n, but only n electrons are filled here. That means only half of them are filled and half of them are empty. So these are the above one are the empty states, and the below one are the filled states. But as we look, the filled state and the empty states are overlapping with each other. The empty states leads to the conduction band, and the filled state lead to the valence band. So what we understand here is empty state and filled state in case of lithium material are going to overlap with each other. As we discussed in the previous class, if there is a difference or the difference in the energy of the empty state and filled state, that material will be either semiconductor or it will be the insulator, depending on that distance. Now we cannot see any distance here or any spacing between the empty state and the filled state. There is no space between the conduction band and valence band. Both are overlapping with each other. Lithium clearly indicates it belongs to a conducting family. It is a conducting material of electricity, or it belongs to a conducting family.